2025 A-Level Combined Mathematics Paper 1 Part B, question number 17 Part B. Question number 17 Part A was discussed in a previous video, link in the top right, and question number 17 Part C will be discussed in a future video, link in the top right. If we consider question Part B, this question has to mostly deal with the sign rule. The question says 4 distinct points A, B, C and D on a plane are such that BAD angle is equal to ABC angle is equal to theta, and 3 times AD length is equal to 4 times BC length. It then says let BAC be the angle alpha and ABD be the angle beta as shown in the figure. So here we can see we have 4 points A, B, C, D, and they are such that this angle is theta, this angle is theta, this angle here is alpha and this angle here is beta. Now given this, it says using the sine rule, show that BC divided by AD is equal to sine alpha times sine of theta plus beta divided by sine beta times sine of theta plus alpha, and deduce that the cotangent of theta is equal to 3 times cot alpha minus 4 times cot beta. Now, as we can see in the figure, there are 2 distinct triangles with the points ABCD. We have the triangle ABC, which is this triangle right here, and we have the triangle ABD, which is this triangle here. If we take a look at what we are asked to find, we can see the side length BC, this side length, belongs to the first triangle ABC. The second side length AD, which is this side length, belongs to the triangle ABD. So as we know, the sine rule only relates the side lengths within a given triangle. So within the triangle ABC only we can use the sine rule, and within the triangle ABD only we can use the sine rule. So if we want to relate AD and BC, which are 2 side lengths in 2 different triangles using the sine rule, what we need to do is to find a common side and apply the sine rule for that side and the common side, and the other side and the common side. Now if we take a look here, we can see that AB is a side that is common to the triangle ABC and the triangle ABD. So therefore, in order to use the sine rule here, what we're probably going to have to do is to apply the sine rule to AD and AB, and apply the sine rule to AB and BC, and then use those 2 relations in order to finally establish the relation between BC and AD. So if we do that, if we consider sine rule for the first triangle, let's say for the triangle ABC first. If we consider the triangle ABC, we can see the angle opposite to the side AB can be found, it's this angle right here, and this angle can be found by the fact that the other 2 angles in the triangle are alpha and theta. So this angle here is going to be pi minus alpha minus theta, since the total angles within the triangle need to sum to pi, and this angle is already taking up alpha radians and this angle is taking up theta radians. So therefore this angle must take up the remaining pi minus alpha minus theta radians. So therefore this angle here is pi minus alpha minus theta, and if we consider the side length opposite to BC, the angle opposite is going to be alpha. So therefore we consider BC, alpha, AB, and this angle. From the sine rule we know any side length, for example AB, divide by the sine of the opposite angle, which in the case of AB, the angle opposite to AB is this angle, so sine of pi minus alpha, actually I'll write it as minus alpha plus theta, is equal to any other side length, which in this case I'm going to take BC, divide by its corresponding opposite angle sine value, which is in this case opposite angle is alpha, so we have sine alpha. So now we have this relationship. If I take the side lengths to one side and the angles to the other side, we can see that we can get BC divided by AB equal to, and if we take everything to the other side, we can get sine alpha divided by sine of pi minus alpha plus theta. Now I'm actually going to directly apply the fact that sine of pi minus any angle is equal to sine of that angle directly. So therefore this is equal to sine of alpha divided by sine of alpha plus theta, and I'm going to call this equation 1. And as for a reason for why I can do this, I'm going to write up here that the sine of pi minus x is equal to the sine of x. I'm going to write this in a box like up here, and I'm going to say that it's being applied over here. So now we have the relation that BC divided by AB is equal to sine alpha divided by sine of alpha plus theta. We can see if we take a look at the equation that they've given us, the sine alpha divided by sine of theta plus alpha is encoded inside of this thing, and we can see BC is on top. But in the denominator we can see instead of AB we have AD. So therefore we need to find AB divided by AD, which if we find and multiply by this thing, we can see we're going to cancel out the AB and AB, leaving us with BC divided by AD, which is what we want. So now if we consider how we can find that relationship of AB divided by AD by considering the triangle ABD, because if we do that, we will be able to use the sine rule to find AB divided by AD. Now if we consider what we have, for this triangle, we have an opposite side of AD, with its opposite angle, which is known to be beta, and we have the side AB, which is the common side, with its opposite angle here, which once again by a similar method to this thing we can find is equal to pi minus beta minus theta, since the other two angles in this triangle are theta and beta. So we have theta here, beta here, which means the remaining angle must be taking up pi minus beta minus theta radians. So therefore, if we apply this now, we can say, considering sine rule for the second triangle, for triangle ABD, what we want is AB divided by AD. In order to do that, we're going to do AB divided by its sine value and AD divided by its sine value. If we consider AB the AB here, the angle opposite is going to be pi minus beta minus theta. So we have AB divided by sine of pi minus beta minus theta, which I'm actually going to write as pi minus beta plus theta, like this, equal to AD divided by its corresponding sine value, which is going to be AD divided by sine beta. So divide by sine beta. Sine beta. Now what we want is AB divided by AD. So if I rearrange this, we can see AB divided by AD is going to be equal to, on the bottom we have sine beta, and on top we have the sine of pi minus beta plus theta, which as we know is going to be equal to the sine of beta plus theta. Once again, of course, we could say on this idea that sine of pi minus x is equal to sine of x. Put that in a box and maybe put an arrow here. So we have this equation here, which we can call equation number 2, and we can see if we multiply equation number 1 by equation number 2, if we do 1 times 2, on the left hand side we are going to get BC divided by AB times AB divided by AD. So we can say we can have BC divided by AB times AB divided by AD is going to be equal to, and on the right hand side we're going to have sine alpha divided by sine of theta plus alpha multiplied by this bit, which is going to be sine of beta plus theta, actually, alright, theta plus beta divided by sine of beta. Now we can see finally we get BC divided by AD as we wanted, and on the right hand side we have they want it in this form, so we'll write it in that form. We have sine of alpha times sine of theta plus beta divided by sine of beta times sine of theta plus alpha, which is exactly what they wanted us to find up here. So we've gotten all the way up to this point. Now finally it says, hence deduce that cot theta is equal to 3 cot alpha minus 4 cot beta. Now I want you to notice here that we have the relationship that 3AD is equal to 4BC up here. Therefore, if we consider BC divided by AD, BC divided by AD is going to be 3 divided by 4. So we can replace this thing with 3 divided by 4. And this is probably what we're expected to do, since here we can see we have the factors of 3 and 4 in front of cot alpha and cot beta. So therefore what I'm going to do is I'm going to consider down here, since AD times 3 was equal to BC times 4, I believe that's the correct relationship. Yeah, 3AD equals 4BC. Since 3AD equals 4BC, we can say that BC divided by AD is equal to 3 over 4, and therefore 3 over 4 is equal to sine of alpha times the sine of theta plus beta divided by the sine of beta times the sine of theta plus alpha. So now what I'm going to do in order to turn this into the expression that we want is to cross multiply, and then I'm going to get that 3 times the sine of beta times the sine of theta plus alpha is equal to 4 times the sine of alpha times the sine of theta plus beta. Now, what we're going to have to do next is to expand each of these expressions, this expression and this expression, using the formula for the sine of one angle plus another angle. Doing so, we are going to get 3 times sine of beta times sine theta cos alpha plus cos theta sine alpha. This is the expansion of sine of a plus b. It's going to be sine of a cos b plus cos a sine b. This is going to be equal to, on the right hand side, 4 times sine of alpha times the same expansion for this thing, which is going to be sine theta cos beta plus cos theta sine beta. Now here we can see in all of this we have sine beta, sine alpha, and sine theta. We also have cos alpha, cos theta, and cos beta. But in the expression that we had up here, we had only cot theta, cot alpha, and cot beta. Now as we know, cot theta is simply cos theta divided by sine theta. Cot alpha is simply cos alpha divided by sine alpha. And cot beta is simply cos beta divided by sine beta. So in order to get those values, what we're going to have to do is to divide all of the sine beta, sine alphas, and sine thetas out of this expression. What I'm going to do at this step is to simply divide the entire expression by sine of alpha times sine of beta times sine of theta. If I do so, on the left hand side, we're going to get everything divided by all of that. So I'm going to actually write that directly. Divide by sine of alpha times sine of beta times sine of theta. We can do the same thing on the right hand side. We're going to have divide by sine of alpha times sine of beta times sine of theta. On the left hand side, this sine of beta is going to cancel for this, leaving us with 3 times sine alpha cos sine theta cos alpha rather, plus 3 cos theta sine alpha divided by sine alpha sine theta. Here once again, this sine theta is going to cancel for this, leaving us with cos theta divided by sine theta here. This sine theta is going to cancel for this, leaving us with cos alpha divided by cos theta, cos alpha divided by sine alpha here. So we're going to be left with, on the left hand side, 3 cos alpha divided by sine alpha plus 3 cos theta divided by sine theta. And on the right hand side, similarly, this sine alpha is going to cancel for this sine alpha, leaving us with 4 times sine theta cos beta divided by sine beta sine theta, which means this is going to cancel, leaving us with cos beta divided by cos sine beta, which is going to give us 4 cos beta divided by sine beta plus this thing, which is going to be 4 times cos theta sine beta divided by sine beta sine theta, which is going to cancel out the sine beta, leaving us with cos theta divided by sine theta. So plus 4 cos theta divided by sine theta. Simplifying this, we can see we get 3 cot alpha plus 3 cot theta equal to 4 cot beta plus 4 cot theta. Now, simple matter to simplify this down, we can see if we take this thing to the other side and this thing to the other side, we get 4 cot theta minus 3 cot theta, which is just cot theta, equal to 3 cot alpha minus 4 cot beta. So there we go. That is our final expression. It's the expression that we had in the question, and it is the final solution to this question. Now finally, if we consider the marks order for this question, at the start, when you use the sine rule directly like this, you get 10 marks. And then when you simplify the sine of pi minus an angle into the sine of that angle like this, in order to get sine of pi minus alpha plus theta into sine of alpha plus theta, you get 5 marks. Similarly, for the other triangle, triangle ABD, when you apply the sine rule again directly, you get 10 marks. And then when you simplify this sine of pi minus beta plus theta into sine of beta plus theta directly, you get another 5 marks. After this, when you get the 2 equations from the sine rule of one triangle and the sine rule of another triangle, and you then multiply or divide them, it depends on how you get the equations. When you multiply and divide them to eventually get the equation given in the question, which is BC divided by AD equals all of this, you get 10 marks. after that point, when you then use the fact that 3AD is given as 4BC and you then write down that this value here is going to be equal to 3 over 4, you get another 5 marks. When you then rearrange and simplify down and get to this expression and then substitute in sine of theta plus alpha and sine of theta plus beta into this expression here and this expression here like this, you get total of 10 marks. When you then simplify this final expression down, divide everything by sine theta times sine beta times sine alpha and then simplify down to eventually get the final answer of cot theta equals 3 cot alpha minus 4 cot beta, you get another 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.